And so we continue on with the worksheet, going through this to kind of help our idea of some of the themes and concepts hidden in the work of verifying trig identities. And let's start looking at number 9. And so for number 9, where am I going to start is I'm going to keep the left-hand side. It's one term, it's all by itself, tangent of x, beautiful. And one of the reasons why I know this too is it's a simple left side, while the right side has a fraction bar. And they're not like terms. So that kind of tells me I'm going to need to do something. So the first thing is secant of x. Secant of x is 1 over cosine of x, while cosecant of x is 1 over sine of x. So why did I switch to sines and cosines? Maybe I rushed into it there. Who knows if I'm right? And the reason why I did is my mind, when I look at this problem, I see tangent of x. And if it's not squared like this, I mean, how do I create a tangent of x? Well, based off our formulas, we know tangent of x is sine over cosine. So I can even see right away that if I want to end with tangent of x, I probably want to create sines and cosines. And that's what told me to change this right side, the sines and cosines, is something tells me I'm most likely going to end there before I go through. And let's see if that happens. That's my hypothesis. Let's see if it's true. Left-hand side stays. Wait a minute, I am dividing by a fraction. There's a repeating theme that we've had before, is we have to get confident and comfortable with working with fractions. Well, dividing by a fraction is you flip and multiply. Well, are you tempted to cross things out here? Because you can't, because they're not the same. They're not the same factors, so I can't cross them out. But I can combine them. I mean, I get 1 times sine of x, which is sine of x. I get cosine of x times 1, which is cosine of x. And lo and behold, that's what I said was going to happen, that in order to get tangent of x, I would have to get sine of x over cosine of x. And that is what I ended up doing. So sometimes you can kind of see the second to last step by analyzing how do you create it in the beginning. So there's number 9. Yeah, pretty easy compared to some of the previous problems. But do you see the theme? You're dividing by a fraction, so you flip and multiply. For it, do you see the hidden concept of analyzing the problem to see what structure you should try and work towards on the side that you're changing? That I need to get sines and cosines. So there's little things. They're not the same steps, but ideas do remain constant through the whole idea of verifying identities. Number 10. Hopefully you recognize, keep the left side because it's cosine of x, which again tells me I want cosines, but man, the fact that this is a cotangent should bother you because they're not the same. So I'll keep sine for right now. So I'm going to keep that sine of x. But I will change the cotangent of x into cosine of x over sine of x. And then what do? Well, I'm going to keep the left-hand side. And if it makes you feel better, you can put this over 1 and notice it's all multiplication going on here. Again, another theme that has been important to us. So what I'm going to do is I am going to cross out common factors in the top and bottom. And look at that, that was a very quick problem. Cosine of x equals cosine of x. So not all of them are as complicated as some of the ones we've done in the past, but there are certain themes. If you're multiplying, you can cross out common factors in the top and bottom. The idea of what do I change to make my life a little bit easier for the simplifying process. So now let's look at number 9. Again, man, which one do I keep? Which one do I change? And hopefully, based off you're watching all the other videos, is you should recognize I'm probably going to keep the right side. And the reason why is it's sines and cosines. This is a secant and a tangent. They're not the same. So something tells me I probably want to change them. Well, what am I going to change them into? How do I know what to change them into? Well, the right side has sines and cosines. So I'm going to change secant of x. I'm going to write it as 1 over cosine of x minus. I'm going to change tangent of x into sine of x over cosine of x. And I'm going to stop. And hopefully while I stop, you can look at your paper and see automatically what to do. But I want to explain it is look at the side you're keeping as you go along. I want a cosine in the denominator. I have a cosine denominator. I want a 1 minus sine of x in the numerator. I have a 1, I have a minus, I have a sine of x. So really I want to combine these into one fraction. As if I look at my structure, I already have all the terms I want. So since I am adding two fractions together, look at that, that's another theme that we talked about before. You need to have a common denominator if you're adding or subtracting two fractions. Well, in this case, you already have it. So you don't need to create it. And that is really nice when that happens. So I have 1 minus sine of x over cosine of x. And on the left side, when I merge them, I do get 1 minus sine of x over cosine of x. Q, E, D. So even though you didn't create a common denominator, the theme was still there of adding and subtracting two fractions. It has to be there. If it's not, you create it. If it is there for you automatically, well, that's just called good. We can work with it. So let's look at number 12. What am I going to do on number 12? And we can think through the process to figure out all the techniques we're going to work with. So which side do I keep? Which side do I change? And hopefully you realize you should probably keep secant of x because it's one term. And before I figure out what am I going to do to this left-hand side, I'm going to think about the right-hand side some more. How do I get a secant of x? Well, that tells me it's 1 over cosine of x. So something in me thinks this is going to play a role in creating it. And I need to keep that in mind because this left side just looks awful. And even I am tempted. I'm tempted by this to go, well, look at that denominator. Maybe I should try a conjugate. And my mind was tempted to go there. And the reason why I know not to do it is, let me write it out, is it gives me sine of x minus cosine of x as a conjugate. And when I multiply these, I'm not going to get a Pythagorean identity. And so I stop because I realize if I do it, I can't simplify the bottom any further. So don't think, oh, I have two terms with a plus sign or minus sign at the bottom. That guarantees me conjugates. It's not how it works. That's an option. And if you try it out and you see that you can't simplify, well, then you got to get the eraser out and you're going to have to erase and just start from different spots. So I'm saying even I, when I look at this, am tempted to think conjugates. But when I see it, it didn't work. So then what am I tempted to do next? I'm tempted to switch into sines and cosines because I want a cosine. And there's a tangent here. I don't want that. And so what I'm going to do is I am going to write this as 1 plus, and I'll change tangent into sine of x over cosine of x. And the bottom, I'm just going to keep this alone because it's already sines and cosines. So I'm tempted to go to sines, cosines, and so far I'm happy with it because it hasn't made it look too bad. And you may think it has because there's a number plus a fraction. So you create another fraction inside the fraction, so it looks more complicated. But to me, that doesn't. Because to me, that looks like a theme that we've been dealing with. Is that if you're adding a number and a fraction together, you need to find a common denominator. So I start to see a concept reappearing constantly. And so in this case, if I want to merge these into one fraction, let's keep the bottom, I need a common denominator. Well, 1 is going to be cosine of x divided by cosine of x. And that gets me my common denominator. It's what I wanted. I wanted cosine of x, so I created it. I multiplied the top and bottom by cosine of x over cosine of x. Well, how is that helpful? Because now I have a common denominator. I can merge the two fractions together into one fraction. So I have a cosine of x on the bottom, because it's a common denominator now. And on the top, I have a cosine of x plus sine of x. So this whole thing was now merged into just one term. And again, that's repeated anytime we combine fractions, get a common denominator, and merge them together. So let's see what happens. My denominator stayed the same. I didn't change it at all from the beginning. So is this helping us? So we'll pause for a second and let's go back to see what I wanted. So my instinct is telling me that if I want secant of x, I better end with 1 over cosine. Am I getting there? Well, I do have still too many fractions, but if I look at this fraction, I do see a cosine on the bottom. And that's standing out to me. I like that. I like that there's a cosine under the fraction bar. It makes me feel comfortable that I may be on the right track. So let's see what happens. Again, I'm dividing. And if I take a fraction and I'm doing division, we do have other themes that start to reappear. We flip and we multiply. So cosine of x plus sine of x, the numerator stays the same, but when I divide, I multiply by the reciprocal. So really this is over 1. So I'm going to multiply by 1 over sine of x plus cosine of x. That's another theme. Divided by a fraction, multiply by the reciprocal. Well, why is this helpful? Like, again, you have these plus signs with two terms, and I'm going to look at them as factors. So I'm going to put them in parentheses. Look at this. I'm multiplying. Well, when you're multiplying, you can cross out common factors on the top and the bottom. And these are common factors because addition is commutative. 3 plus 2 is the same as 2 plus 3. So sine of x plus cosine of x is the same as cosine of x plus sine of x. Let's see what we have left. When those cross out, I'm left with a 1 over cosine of x equals secant of x. And if I were to zoom out and take a look, that is exactly what I said should happen. In order to get secant of x, I better first get my 1 over cosine of x. And I did. So I better write secant of x equals secant of x. QED has been proven. 1 plus tangent of x over sine of x plus cosine of x equals secant of x. Now this one you would say is probably more complicated on this entire side when it comes to 9 through 12, and I'm going to agree with you. 12 is probably the harder one between them. But we should notice some themes here. Is I am adding to a fraction, so I better find a common denominator, and when I do find a common denominator, I better merge them together into one fraction, and that's exactly what I did. Well, have we ever seen that before in other problems? And the answer is yes, we have. And so let me just take a minute in the video and go back to some of the previous ones that we've dealt with. We've dealt with common denominators before. And if I go back, we'll go back to this video up here when we looked at questions 1 through 4, is the first problem dealt with adding two fractions together and creating a common denominator. And then we got to merge them together. So those 3 steps, not the same trig ratios, the same concepts are there. And even here, I'm adding 2 fractions. So number 2, I had to create a common denominator. And that allowed me to merge them together into a single fraction. Not the same steps, not the same trig ratios, but the concept is there for us. So don't think that they're all different. There are overlapping themes here, even divided by a fraction and so on. So hopefully you understand, and we'll have one more video to go over the last 4.